Hey, welcome back to Code Library. So here I have come back with the second part of UV demonstration. I hope you have seen the part 1 of this video. So if you have not seen it, please watch it, and I have put the link in the description below the video. Now, just to give a quick recapitulation, in the first part we described what UV is as a Python package manager and how it compares to other Python package managers, as well as we ran certain UV commands, right? And for example, we have run the UV init command to see how to initialize a project with UV, and then we have run the UV venv command where we have seen how to create a virtual environment using UV. Now, in the first part of this UV demonstration, we have seen how to create a named virtual environment where we provide a particular name for our virtual environment. In this second part of this particular video, we'll see how to create a unnamed virtual environment where you don't provide any name to the virtual environment. Okay, so let's get started. Okay, so in this video we'll start with how to run a UV how to run a Python script using UV command. Normally we run the Python script. For example, we have a script called main.py here. You can run using the command python then space main.py, right? But you can run a you can run a Python script using UV as well. So since we are continuing with the named virtual environment as we created in the first part of this UV demonstration, you remember the name of the virtual environment was UV demo env, right? So let's see how to run a Python script using UV. So the command is UV run. Now we'll use the active flag because we are using the named virtual environment, and then you have to provide the name of the Python file. For example, here it is main.py, right? Let's hit enter, and here you can see hello from UV demo. Above is a Python script, and here you can see it's hello from UV demo. So we can run in this manner using the UV run command. Now, important point what I'd like to mention in this video is that we need to use a UV cache directory. It is not mandatory, but when you use a UV cache directory, it is a great idea for managing dependencies across multiple projects, and it helps us to save disk space, speeds up installations, and simplifies cache management. Just you need to set an environment variable which is UV underscore cache underscore dir, and this environment variable has to point to your cache directory. So let me show you where I have created my cache directory. So let me open the Explorer, and if you go to this folder, here you can see I have created a UV cache directory. Now let's open it, and here you can see UV has done a lot of activities over here. And to set the virtual environment, the path here is, if you open UV cache and if you go to web, the path is f/UV cache, right? Now let's open the environment variables, and if you open the environment variables over here, you can see I have set an environment variable which is UV underscore cache underscore directory, dir. Now this is, I'm using Windows operating system, and if you're using a Linux or Mac OS, then of course you know how to set an environment variable in your operating system. So this will work either in all kind of operating system, only the methodology to set the environment variable is different for these platforms, right? So let's cancel it. So if you use this UV cache directory, as I said, it will help you to save space and speed up installation, and as a result, overall, the cache management will be simplified. So let's get back to our IDE once again. And now we'll see how to manage Python versions in UV. Okay. Now, if you remember, we ran this command earlier. So the command was UV Python list. Okay. Now this command actually lists all the available Python installations, including which can be downloaded and installed. Let's run this command. Before that, I'll expand this terminal and let's hit enter. And here you can see, if you remember in the first part of the video, we talked about these two as system-wide Python installation, not this one, sorry, these two, okay? These two as system-wide Python installation, which I have installed using basically installer of Python, okay? Now, this is, you can see, one is 3.13.1 and another is 3.12.8, right? Now, apart from that, there are other installations which are done by UV when I had been experimenting with UV. But you can see this is cluttered with things like this: download available, download available. So you can install these versions of Python as well. So there is another variation of this command. Let me clear the screen, which says UV Python list, and then you put this flag only installed, okay? Only dash dash only, then installed. And if you hit enter, you will see a cleaner output where you don't see the download available stuff. And here you can see these are the two system-wide installation which I have installed myself using Python installer, and these are all these installations which are installed by UV itself. And you can see the installation locations are a bit different, right? Now let's come to the main topic, which is how to manage Python versions in UV. Okay, let's open this file. Let me clear this terminal first. Okay, and if you open the pyproject.toml and also the python-.python version file, here you can see I am using 3.13.2, and if you go to pyproject.toml, here you can see 3.13.2. Now, if you want to install a different version of Python in this same project, you can definitely do that. There is UV provides command for that. Now we have 3.13.2, and let's say we want to switch to 3.12.4, right? Now for that you need to make certain changes before you actually run the command, and the command is UV sync. So let's change it. Let's say we want 3.12.4, right? Now you need to make both the changes in both files, pyproject.toml as well as Python version. Now let me hit enter, accept the change which is offered by my AI environment. So this is 3.12.4, and let's save both files. Okay, now you can switch Python versions for your current UV project at any point, as long as the new version satisfies the specifications in your pyproject.toml file, which are the dependencies basically. So you should know what you are doing actually. Okay, so let's now run this UV sync command. Right now the command is UV sync, and since we are using a named Python virtual environment, we need to provide the active flag. if you are not using the name Python virtual environment, where you are creating the virtual environment using the uvvnb command, then you can just put uvsync and that's enough. Now, since you are using a named Python virtual environment, which is uvdemoenv, I'll add the active flag. Okay. Now, let's see what happens. Now, what will actually happen, I'll tell you. But before that, let me run the command. So here, using CPython 3.12.4. So what actually happens is, the command actually first checks against the Python installations. If the requested version isn't found, it downloads and installs it. Now, EV also creates a new virtual environment inside the project directory and replacing the old one. You'll see that. You'll see that in the command. It's taking time. So let's wait. And here you can see it says remove virtual environment. And then it is recreating the virtual environment once again. Obviously, because, it is changing the Python environment, and we are switching versions from 3.13.2 to 3.12.4, and obviously a new virtual environment need to be created which suits the dependency versions, right? So here you can see it is resolving the packages, and it is almost done. Let's wait. Okay, so here you go. So you have run the uvsync active command with the active flag, and here you can see it says resolve 25 packages and in 5 seconds and install 2 packages, and it actually removed the uvdemoenv and recreated that particular environment once again, right? Now, if you want to switch back, let's try to do that once again. Switch back to the previous version. Let's say uv13.2. That's also possible. uv13.2, and in the Python version 2, we use uv13.2. We do a save all for files. You run the uvsync and with the active flag, and here see what happens once again. And here you can see it is using CPython 3.13.2, and it will now remove the virtual environment as well as recreate the virtual environment once again. Let's wait and see. And here you can see it removed the virtual environment and it's recreated the virtual environment once again, and it is resolving the packages, and of course the reinstallation of all the packages will happen in this virtual environment once again. So it's taking a bit time. So here we go. So let me expand the terminal, and here you can see when you switch back from Python 3.12.4 to back to 3.13.2, you can see again it removed the virtual environment, recreated the virtual environment, resolved all the packages, and reinstalled all the packages in the new environment. Okay, so that's the way you can use the uvsync command to change Python version. Okay, so let me clear the screen, and now we'll see how basically to use UV tools. Now there are certain Python packages which are exposed as command line tools, and I'm telling you the name. The names are, for example, black, which are used for code formatting. Then there is flake 8 for linting. Then there is pytest for testing, and then there is mypy for type checking. Now EV provides spatial interfaces to manage these packages. Okay, so let's see a few tools and how to run them. Okay, so as I said in the beginning, there is a tool called black, which is basically a Python package, and you can run this tool. First we'll use, let's say black is for command for code formatting, so we'll use this main.py, and let's say I put an extra tab over here on the print, right? Ideally it should be one tab in Python, right? So we'll put an extra print. Now take care to save the file before you run the tool. Now I've saved the file, right? Now I'll run the black tool, which is uv tool, then run, uv tool run. This is a command basically, and then the tool is black. Okay, and we are applying this black tool on the Python file main.py. Now watch out at the top, the main.py. We put an extra tab over here, and when we run this, we'll hit enter. Here you can see it says all done, one file reformatted, right? And here you can see we have a single tab, the one tab was removed, and proper code formatting was done by the UV tool black. Then there is another tool, as I said, which is flake8 for linting errors. Let me clear the screen, right? And I'll just increase this a bit. And let's say we purposely introduce an error, we remove this colon, right? And here you can see a red squiggly line over here showing in the ID that this is a linting error. We'll save the file once again before we actually run the command. So the command is again uv tool run, and then the command, the tool is flake8, F-L-A-K-E, then 8, and we are applying it on the file main.py. Let's hit enter. Now what happens here, you can see it says error 9999, error 999, right? And it says syntax error expected colon in the line 1, right? And here we go, we change it as indicated by flake8, and we'll resave the file. So in this way you can run Python packages like black, flake8, pytest, mypy. You can run these as UV tools. Now when these commands are run, UV creates basically a temporary virtual environment in its cache. The requested tool is installed and run from there, right? In other words, you can use command line tools without installing them in the project's virtual environment, and this results in further faster execution and cleaner project dependencies. Now there are key points about these tool interfaces is that they work with Python package that provides command line tools like flake8, mypy, black, or pytest. And now cached environments are automatically cleaned up when clearing UV's cache, and new cached environments are created on demand when needed. Okay, so that's all about UV tools. Now we'll talk about log files a bit more. We have talked about log files in our first part of this UV demonstration. Now the log files, which is UV log, over here you can see the UV log file, and these log files are essential part of dependency management in Python using UV. Now when you run UV add command, which I have run in the first part of this UV demonstration, when you run UV add command to install dependencies, UV automatically generate and updates a uv.log file. Now UV manages the log file automatically, and you don't need to manually edit it. The log file should be committed to version control to ensure all developers use the same dependency version. So if you are using Git, for example, in a Git repository, you should not mention it in the git.gitignore file. Rather, you should version it, and hence you should push it up to other repositories. For example, GitHub, if you are trying to use a web-based Git hosting. Okay. Now you have also heard of the requirements.txt file, which we frequently use for deployment of dependencies, and we use requirements.txt frequently when you're using pip instead of UV, right? Now you can maintain both the files, which is uv.log and requirements.file, and use uv's log file for development and using requirements.txt file for deployment. Now you can generate a requirements.txt file from uv log file using this command, which I'll show you right now. So let me expand this once again. And we don't have a requirements.txt file, as you can see in the left sidebar, and the command is uv export -o, so you can use -o or double dash output, both will work actually. So it is -o here only, -o, and then requirements.txt, right, .txt. So what happens is uv exports all the dependencies from the uv.log file and dumps them into the requirements.txt file. So it will create this file as well. So let me hit enter, and here you go. So you can see a new file, requirements.txt file over here, and if you open this file, let me remove this, and here you can see this file was auto-generated by uv via the following command, which is uv export o requirements.txt. Now this does not look like the normal requirements.txt if you have seen already, or if you have worked with requirements.txt. It looks a bit complicated. Now this is because of this hash. You can see the hash, right? Now this includes this cryptographic hashes for each package, and this is basically a security feature, right? Now if you want a simpler requirements.txt file, then you can use another command, which is ub pip freeze. So I'll show you that as well, but before that I will open this terminal once again. So what I'm going to show you is that I'll delete this requirement.txt file once again. I want to show you another alternative command. So the command is uv export requirements.txt, and instead of -o you can use this arrow or the redirection sign, right? Let's hit enter, and here you can see you have the requirements.txt once again. So uv -o requirements.txt and uv export -o requirement.txt and uv export with this redirection operator or the arrow requirements.txt both work in the same manner, right? Now let me show you the command which you can use to get a simpler requirements.txt without these cryptographic hashes, which is also called basically hash pinning, right? So let me clear the screen once again, and let me delete this requirement.txt, and I'll show you the command where you'll get a much simpler requirement.txt file. So it's uv pip freeze and then requirements.txt. Requirements.txt. Let's hit enter, and here you can see the requirement.txt is again generated, but here this time it looks much simpler without those cryptographic hashes. And here you have all the dependencies listed, include the direct dependencies such as numpy, pandas, which you installed in our first part of this video, and then you installed matplotlib, if you remember properly. So I can't see matplotlib, it should have been here. I think I have removed it. So you have the direct dependencies as well as the transitive dependencies as well, right? Okay, so far in this video, and as well as in the first part of this UV demonstration, the part 1 video, we have used a named Python virtual environment, and as a result, when you have been running certain commands, UV commands, you have been using the -- active flag. Now this is not required if you don't use a named virtual environment. Now we'll create another UV project, which is UV demo 2, and I'll show you that. So let me close this IDE. So here I have created another folder which is UV demo 2. So I'll right click and open with Windsurf, right? So our IDE opens. Now if you don't know, or if you have not watched the first part of this video, so Windsurf is basically a IDE AI enabled integrated development environment, and basically it is a fork of the Visual Studio. So it looks almost similar to the Visual Studio. Okay, so here is UV demo 2, right? Now I'll open a terminal, control backtick, and here we are in the UV demo 2. Now we'll see how to create a UV project without a named virtual environment, and it will work almost similarly. And the convenience is basically we don't have to use the -- active flag. So let's run this UV init command, right? So first we'll initialize the project using the UV init command. And here we are not providing any name of the folder because we are in the project folder itself, which is UV demo 2. So let's hit enter, and here you can see the standard set of files with the Python version, main.py, pyproject.toml, and readme.md, and gitignore are created. Let's see what is the Python version. So I have the latest Python version, which is 3.3. In our first part of the video, we have used, if you remember, the command was something like this, UV init. Then we used the name of the Python version environment, which was, if I don't remember, it was something like UV demo, probably. No, UV demo env, right? And then we mentioned the Python version, which is Python equal to 3.1.2. This was the command we run in the first part of the video. So here we are not using Python version, so automatically it picked up the latest version of the Python which is installed in my operating system, which is 3.13. And we have initialized the project. Now we'll create a virtual environment. So this time we'll run uvvenv command and will not provide any virtual environment name. Last time the command we ran in the first part of the video was uvvenv, and then we gave the name of the virtual environment, which was uvdemo venv. Now this time we'll not do that. This time we'll simply run the command uvvenv. venv stands for virtual environment. So let's hit enter, and here you can see over on the left sidebar a .venv folder. So let's go to our project explorer, and here you can see venv. We'll go to lib, we'll go to site packages, and here you can see no dependencies are installed. Right now we'll activate this environment. Right now we'll activate this virtual environment. Here you can see it says activate with venv scripts activate. So the .venv folder is located in this current directory. So we'll hit enter, we'll write scripts, then active and activate. Okay, let's hit enter, and here you can see it is activated. Let me expand the terminal, and now we'll actually run this add command, which is uv add command, to see whether these dependencies are getting added in this site packages folder or not. Now last time when we ran the command, which is uv add, and let's say we want to install the Python package pandas, and last time we had to add this active flag in order to ensure that the package got installed within this particular virtual environment. But this time we are not using a named virtual environment. As a result, we don't need to add the -- active flag. So we'll install pandas, and let's hit enter, and here you can see it is going ahead with installation. It's very quick, and the pandas is installed, and there are, as a result, Pandas was a direct dependency, but it requires several other transitive dependencies. It requires NumPy, Python detutil, and all other things which UV has installed. Now let's go ahead and check our site packages folder, and here you can see, despite the fact that we have not used the -- active flag, the Python packages have got installed in the virtual environment, and the folder is VNB live site packages. Okay, so with this we end this video. Hope you enjoyed it. Please don't forget to like this video and subscribe to the channel. Thank you. See you again in the third part of this UV demonstration.